Continuing on with class 23, here's an example of a branch circuit, and we're going to find out that not so easy to solve. That's really one of our big takeaways into this, but we're going to be able to solve it. And I found a workaround. Instead of using a software package, that would have been nice, but I found a Wolfram Alpha, a way to use a feature in Wolfram Alpha to numerically solve it, and I'll show you what their results are. So we have these three tanks, and they're connected with pipes containing a friction factor. So I guess the pipes have the friction factor of 0.03. Determine the water velocity in each pipe and neglect minor losses. So they give us the diameter and the length of each of these pipes. And we also know that this thing has an elevation of 838 feet, 850 feet, and 805 feet. And the truth is, we don't know which direction this is actually going to flow. This is the highest one, so maybe this is going to flow downwards, likely. But is it going to go to here? Or is this one going to drain down to here, right? So are these going to merge together and then go to C? Or is this one going to go down here and split between going from B to A and B to C? We don't actually know, but we should first guess. That's the approach that we're taking here. All right, so I'm going to go ahead and assume that that they're going to go in this way right there, and that way, right? So that this is my assumption that we're making right there. So that's going to say, I just think I'm going to switch to Q's. So I'm going to say that Q3 is equal to Q1 plus Q2, right? So we have, this is going to be, which way are we going to call it? This is, which one's 1 and which one's 2? I guess this is 1, this is 2, and this is 3, right? So Q3, coming down there, Q3, and this is Q2, and then this is Q1. And well, we know we're going to do everything in terms of velocities because we need it in terms of velocities to be able to use this friction factor. So we say that we have A3 V3 is equal to A1 V1 plus A2 V2, or pi over 4 D3 squared V3 equals pi over 4 D1 squared V1 plus pi over 4 D2 squared V2. Of course, all these cancel out right there. So we just have 1.2 squared V3 equals 1 squared V1 plus 1.1 squared V2. So working through this out and solving for V3, we get an equation 0.694 V1 plus 0.840 V2. And then we'll call that equation 1. Now we have, let's figure out right here. So that really is a node problem right there. We could think of that as the Kirchhoff of current law, that we had to split, right? That this right here went in, this right here. We're at a node. Now we need to do a loop, and there would be like maybe 3 possible loops, but we only need to do 2 loops, right? One of the loops we're going to do is going to go from A to C, and the other one's going to go from B to C, right? And there's no need to go from A to B, right? So when A to C, B to C, no need to go from A to B. That right there would be like a redundant one, right? right? So we need to have three equations. They need to be independent equations, but that would not be an independent equation going from A to B. We only need A to C and B to C. So let's go A to C first, and that's going to be Bernoulli, right? We're going to write Bernoulli from here to right here. So this was the conservation of mass, and now we're going to do what's essentially the conservation of energy, because that's what Bernoulli is. So we go PA over gamma. That's where we're starting. And V plus VA squared over 2G. But by the way, remember that velocity is not the same as this velocity. That's the velocity right here at that spot at A. Plus ZA. And we should really write out, this should really be minus, but I'm going to go ahead and put the head loss over on the other side, right? So really the head is going to be minus on this side, but I'm going to go ahead and put it as a plus on the other side. So this is PC gamma plus VC squared 2G plus ZC, and then plus my head loss. So the head loss. Well, let me write it down, and I'm not gonna, so I don't have to rewrite the thing out. We know that it's going to be the friction factor, which is the same everywhere, so that's kind of makes it life a little bit easier. It makes it so that we don't have to use the Reynolds number to find that friction factor, because we don't know the velocity, so that becomes a really more complex thing to have to do. If we didn't know the velocity, if we didn't know this friction factor, we need to find it by finding the Reynolds number. And to find the Reynolds number, we would need to know the velocities, which are the unknowns. So it was nice that they got that. That's a very simplified, things that really helps to simplify. But we're going to take the L1 divided by the D1 right there, right? Because it's going to be different. So it's the head loss right there. And that's going to be, this velocity is the one that's inside there. So V1 squared over 2G. And then this is in series coming down. And so that's going to be plus FL3 divided by D3. And that's going to be V3 squared over 2G. That's atmospheric, that's atmospheric. This is stagnant, that's stagnant. We're assuming the tank's big enough that we get rid of there. So what we're left with is this equation right here, which we're going to have. So ZA is 838. It's going to be equal to ZC, which is 805. And then plus 0.03. from right up there. And then the 800 over 1. And now the V1 squared over 232.2. All right, and now we're going to do the other leg right here, plus 0.03, and now go the 600 divided by 1.2. And now the V3 squared over 232.2. So work all this through, and we're going to have a 33 feet. That's just that one, this one minus that. It's going to be equal to, and we get values of 0.373 V1 squared plus 0.233 V3 squared. I'll underline these, and that's equation 2. One last one we have to do. We're going to have to go from B to C. Right? So we're going to go from here to right there. So we're going to start out with PB. It's all the same thing. I mean, I could probably, if I could figure out a way to make these videos fast forward through this, I probably would do it. But I don't want to take the time to go through the editing software. I have Camtasia, but I'm using, what the heck is this thing called? I forgot. What's the name of this thing? Chimera? Cultura Capture. the school bot. Let's see. So we're gonna have plus F, and now it's gonna be L2 over D2, and then V2 squared over 2G, and then plus F, and then L3 over D3, V3 over, and then this is unsurprisingly going to be the same value as up there, right? So we're going to end up getting the same thing right in here. It's like this is going to be different, and then of course these are different, right? So those cancel out. These are both 0, so we're left with ZB, which is 850, right? It's going to be equal to VC, which is once again 805. And then we're going to go plus, and get the 0.03, and now it's going to be L2, so that's 700 over 1.1. Did I do that wrong before? No, I think I get it right. 700 over 1.1. And then V2 squared over 2 times 32.2. Put the numbers in. And then this one's going to be the same as the one up above, because it's still the 600 over 1.2, and then V3 squared over 2, 32.2. So working through this, we're going to get 45 when we subtract this from there. So 45 and equal to 0.296, and V2 squared plus 0.233 V3 squared. And this is going to be equation 3. So we have 3 equations, 3 eqs, and 3 uncs. So we can solve it, right? Wrong. This is tough. This is a tough thing to do, and I can show you what the solution manual. This is a Munson problem. What they do is sort of crazy. It's an algebra. It's not a fun algebra tour, and it's even kind of difficult to sort of follow. Here's some of my notes in here. Is what they say first to do is to subtract equations 2 from 3, right? So you subtract them from each other, and we get V3 right here. We're able to solve for V3 to obtain this. No, excuse me. This is from 4, right? So from 3 we get. See, I'm trying to always have to subtract 2 from 3 to obtain this right here. And then says from 2. Okay, yeah, you could subtract there. It says now it says or, and I was like, well, what do you mean or? And then when combined with 1, and I'm like get totally lost. Like, what do you mean by that? To combine it with 1? And then they said, okay, well. Let's just assume that I could get to this spot right here, which can be simplified to this. And then they square that equation after simplification. And they get to this thing to the 4th. Well, they take the quadratic equation of the thing. And they say, voila, that's the answer. Well, there was this program I used in college called TK Solver. It still exists, and it could do this numerically. It was a pretty slick program. I liked it a lot. You could also use something engineering equation solver called EASE. See, it's pronounced EASE. And they used to come with a lot of textbooks, but I don't think it does anymore. Like this Sengel thermo book used to come with a my Sengel book did, at least, came with this, and it had it's a pretty nifty program, and it can do that multiple equation thing, but unfortunately we don't have that available to us. But what we can do is I could go to Wolfram Alpha and I go multiple equation solver, and it gave me a couple choices here. It says simultaneous equation solver. I'm not sure which one I went to. Let me go to this one first. Let me see if it goes there. And those are two equations. But let's see, I guess I went to the other one. So I must have gone to this one right here. Okay, so this is for 4 equations. But let me go to the one that has 3 equations. Right there. All right, so I don't know how to get to that directly. Maybe if I go on system of equations, but here he is, right here. And does it already have this stuff? No, it doesn't have the stuff. All right, so I decided to go A's, B's, and C's instead of going V1s and V2s onto here. But let me see if I can get this to work right in here. So here is my equation 1. I decided that V3 was going to be C. So I said C is equal to 0.694 times, I called 1A, plus 0.84 times B. Boom. That's equation 1. Then I came down to here and go to equation 2, and I went 33 is equal to 0.373 times A squared plus 0.233 times C squared. And then for this last one, we're going to get 45 equals 0.296 times B squared, and then plus 0.233 times C squared. A double, triple check. I think so. Hit compute. Computing, thinking, and it has given us several options that could possibly exist. If we go back through the solution right here, and we might have to double check. We might have to check each of these to see if they're logical. Like the negatives don't really make sense, but it's a possibility. We might want to check it to see if it makes logical sense. But I believe this right here is the one that agrees with this solution right here, where V1 is equal to 4.73, right there, 4.75, right? V2 is 8.35, and so we get 8.30, and then V3 is 10.3, and we can see we get 10.272. So this one right here appears to be the solution by way of doing this, by doing the simultaneous solution of these 3 equations. Once again, remember that the difficulty here is because it's squared, right? That's why we would have so much algebra trouble with making finding the solution. But anyway, the homework problem that I've assigned is much easier than this. Doesn't require the algebra can be done without using this. But if you want to go ahead and use it, that's fine by me. It's going to be an extra credit problem now. So that is the end of this video. And once again, happy Thanksgiving. I'm thankful for you, and I appreciate all your hard work.